Hey everybody. So we're looking at 10.8 today, and the purpose of this lesson is to interpret the discriminant. All right, and we'll get into what the discriminant is. You can kind of see here, but really what its purpose is, and then we'll move on from there. This will be a pretty quick one today, pretty simple stuff. So go ahead and get the title, copy this example of what the discriminant is, and then we'll get into it. Okay, so as you guys probably noticed, right here is the quadratic formula. All right, something we didn't really put a name to, but this value that we get underneath the radical is called the discriminant. All right, and what we can do with the discriminant is figure out how many solutions our equation has. Okay, and so basically that's what we're going to get into today. I'm going to show you how to figure out how many solutions we can get by just looking at this number. All right, and really this next slide is what it's all about. All right, so here's the idea. If our discriminant, which again is the b squared minus 4ac, if that value is greater than 0, we have two solutions. All right, meaning x equals, this, or x equals that. All right, and that's kind of our typical thing that we run into when we're solving these quadratics. We often came up with two answers, right? Like a plus or minus, or x equaling something, or another thing. But there's also the option that our quadratic equation would get just a single solution. All right. And what happens is we can figure out that we're going to get a single solution or one solution when our discriminant is 0. If we get a 0 underneath that square root, we have one solution. All right. And then the last thing is if we have no solutions, all right, that's when our discriminant is less than 0. All right. And just by the way, that should kind of make sense. We've ran into problems. If you guys remember, a number less than 0 obviously gets into negatives, right? So if our discriminant is a negative number, we're getting the square root of a negative, say, for example, -5. Okay, and if you guys remember, when we ran into that, we had to say no solution. All right, and that's the case here. All right, so this is doing some things that we've already seen, but we just didn't really put a name to it, and we didn't really break it down into either having two, one, or no solutions. Okay, so that's kind of the purpose of today's lesson. All right, the next thing I just want to point out is this, I guess, little graph here or chart, right? It says what we just did, okay, but also when it comes to graphing, when you are graphing a quadratic, remember we get a parabola. This is what we are doing. All right, two solutions means it crosses the x-axis two times, right? X equals this or x equals that. Okay, when we have one solution, it's crossing the x-axis just one time. All right, and when we have no solution, it's not crossing the x-axis at all. All right, so just something good to know if you were to be graphing a quadratic equation. All of them still give you a parabola. It's just where does that parabola cross the x-axis? Okay, cool. So yeah, we're just going to try out some of these. So let's go ahead and take a look at 3 examples here together. So go ahead, copy this, and we'll try it together. Okay, so here's our equation. First thing they want us to do is, write the discriminant and then use that to figure out the number of solutions. And again, that's really the purpose of this lesson. So discriminant, again, if it helps, you can put it above this. It's the b squared minus 4ac. All right, and we're just going to plug in those values here. So let's go ahead and do it for letter A. You guys know that, this is my A value, B value, C value. So if I'm doing b squared, my b value is a 6, so I have 6 squared minus 4 times a, which is 2, times our c value, which is 5. All right, and let's see what we get here. So you can grab your calculator. So 6 squared is 36. Negative 4 times 2 is -8. -8 times 5 gives me -40. All right, so it looks like my discriminant, I'm getting 36 minus 40, -4. Okay, so the question is how many solutions, if my discriminant is a -4, how many solutions does that mean I have? Well, since this number is less than 0, I know that means we have no solutions. This would be an example where we would have a negative radical, and that means no solution. Okay, or sometimes they would say zero solutions, but I like no solution. Okay, let's try it out with letter B. So we have, again, we're using our discriminant. So first thing, let's plug in our B value, which, by the way, in your notes, you can probably spread these apart. I'm going to divide them or separate them with these lines just so we don't get too visually messed up here. Okay, so B squared, here's the question. What is the B value of this equation? Okay, I don't see a B value. All right, so what that means is it would be 0. All right, and we saw that not too long ago. So B squared minus 4 times our A value, which is this invisible 1, times our C value, which is this number by itself, which is -7. Okay, so let's see what we get. 0 squared is 0, so I get 0. And then -4 times 1 times -7 gives me a positive 28. Okay, so it looks like my discriminant is 28. So what does that mean? How many solutions do I get if my discriminant is 28? Well, the big thing to realize is 28 is a number greater than 0. So that means we're given 2 solutions on this. Okay, and you guys remember 2 solutions. That's kind of the typical amount of solutions we get when dealing with quadratics. No solutions is not that often ran into, and then 1 solution is even maybe less likely to run into. Okay, but yeah, last one here. Let's try it out. So again, B squared. Our B value on this one is a -12. So minus 4 times A, which is 4, times C, which is 9. All right, so there's my thing. Let's see. So -12 squared gives me 144. -4 times 4 is -16 times 9 gives me -144. All right, and we're getting something you probably might have expected because we're kind of getting an example of each thing. But our discriminant on this one is a 0. All right, and again, when our discriminant is equal to 0, that is when we have just 1 solution. Okay. Just so you guys can kind of imagine, say we were doing the quadratic formula and we ended up getting 0 underneath our radical, right? The square root of 0 is 0. So what happens is the plus or minus 0, it just disappears. So really there's no longer a plus or minus. There's just a single, there's just 0 left over. So that's why we end up with just a single solution and not 2 solutions. Okay. All right, so I'm gonna have you guys try one of these on your own here. This is asking you to find the number of x-intercepts of the graph of y equals x squared minus 3x minus 10. Okay, just to kind of give you some context, when they're saying the number of x-intercepts, that's just another way of saying how many solutions do we have. If we have 2 x-intercepts, we have 2 solutions. 1 x-intercept, 1 solution. No x-intercepts, no solution. All right, so it's just sort of another way of phrasing this, but it's in the context of intercepts. All right, but it's the same idea. If you get 2 solutions, you have 2 x-intercepts. Okay, or so on. Okay, so go ahead and try this out. Plug it into the discriminant, which again is b squared minus 4ac, and see what you get. Okay, so my b value is a -3, so I have -3 squared minus 4 times a. My a value is that invisible 1 times c, which is that -10. -3 squared is 9. -4 times 1 times -10 gives me a positive 40. And so it looks like my discriminant is 49. Well, really, I shouldn't put a box around that because that's not my answer. Okay, but there's my discriminant. How many x-intercepts does that mean I have? How many times does my parabola cross the x-axis? All right, well, since this is a number greater than 0, just going back to it, that means it has 2 solutions, which means it has 2 x-intercepts. Okay? All right, so to answer their question, 2 x-intercepts. Okay, so that's the discriminant. It's not something that shows up a lot, at least not in our class, because usually we're trying to see what does x actually equal, not how many I guess, answers, or how many values of x do we have for our equation. We more care about what it actually equals. So it's a good thing to know, but it's just know it doesn't show up a whole lot. Okay, so yeah, it's a short one today, guys. I'll see you.